Well, good morning. This is our seventh presentation in our virtual learning series that we've started during these unusual times, and appreciate all of you joining us today. As Megan said, if you've got questions during this, feel free to raise your hand or use the chat room. We'll definitely have some Q&A time here at the end. I know everybody's been inundated with different topics. This topic, of course, has been coming out as different organizations have been starting to publish their guides, like BOMA and ASHRAE and the other organizations in the building world are talking about safe reopening. We wanted to kind of take some of our takeaways and applications in that. We also are very excited to have some guest experts and health scientists here with us today to help you maybe bridge some of the gaps in some of the talks that you may have seen about that. So we have Rob and Brad from Ramboll here with us today. I'm going to go ahead and do a brief introduction. For those of you who don't know me, my name is Benny Skelton. I'm the president of Cyclone Energy Group, and we appreciate all of you working with us over the years. Those of you who haven't, we certainly would love to work with you, and hopefully through this presentation you can see some ways how we can do that. I'll hand it over. Brad, do you want to introduce yourself?
Sure. I'm Brad Caddick. I'm a senior manager consultant at Ramboll. Ramboll's an international consulting firm. We deal with everything from due diligence to occupational health and safety. Overseas, we have a very mass knowledge of any environmental or health and safety topic you may want to divulge in. I am in the Chicago office. I've been an industrial hygienist for about 20 years. I focus mostly on indoor air quality, testing for Legionella and molds and all that other stuff. Rob?
I'm Rob Rodersman, also with Ramboll. I've been working with Brad for probably over 20 years. I'm also in the Chicago office. My background in training is in education, a graduate degree in epidemiology, mostly, however, in industrial hygiene, focusing on chemical and microbial exposures and controls. Done a lot of work in hospitals. Currently with COVID, I'm part of the Ramboll COVID team that is designing programs for safe reoccupancy or continued occupancy of major international airport, fast food chain, international technology companies, and trying to ground what we know in the science and the practicality of a building operation, because sometimes the two aren't compatible. So that's the world we play in.
Great, thank you, and thanks for joining us today. Our agenda today is we're going to have a discussion about the spread of airborne infectious disease in buildings. A lot of Rob's experience there, going through that. I'm going to talk a lot about the building HVAC operations for safe reopening. And Brad's going to talk about some fun pathogens in building water systems like Legionella. So we'll go ahead and kick off here. I'm going to hand this over to you, Rob. Give me one moment to give you control. Go ahead.
Thanks, Ben, and thanks a lot to you and the Cyclone Group for inviting us to be here today. I'm just going to have a really quick introduction, hopefully to frame the topics of what Ben and Brad will talk about later on related to just COVID in buildings and how it spreads and how we can control it and what are the best control practices. I think we all know by now that the virus itself is packaged into droplets that are exhaled. And we're talking about a novel virus. Novel means new. So we are learning as we go. 4 or 5 months ago, we knew nothing about this. The science is developing, it's evolving, we're learning more. There's still a lot we don't know. What we don't know, it is very, very important, and I hope we figure it out soon, is exactly the size of the droplets that the virus is transmitted in. I've heard them described as globs, greater than 10, 20 microns, don't travel very far, not more than 6 feet, don't stay in the air all that long and settle out quickly. There's now studies showing that we could have some instances where the virus exists in aerosol, which is a smaller droplet and can travel potentially further. So if someone's coughing or singing, we heard about that, the incident with the choir where it spread quickly throughout a choir. So there might be times where the particle size is much smaller. We see it in healthcare a lot. When someone's intubated, they're going to release much smaller aerosol droplets that can potentially contain the virus. But for practical purposes in office buildings, people are speaking, walking, regular breathing, not necessarily coughing or sneezing too much. Hopefully we're keeping that out. the virus is going to be in droplet size. It's not going to travel all that far. It's going to settle relatively quickly, probably within a half hour. So that's important to understand when we're talking about controls. Additionally, when we're looking at the virus, adjust the size. There we go. By far, our primary mode of transmission is going to be direct person to person. Direct person to person. We'll spend a lot of time talking about cleaning surfaces. That cleaning surfaces is important. It's still unknown how much disease is actually transmitted from someone touching a surface that is contaminated and touching a mucous membrane. In theory, it's possible. We don't think it's occurring all that much. But since we don't know, we still need to keep up with our cleaning protocols. But when we want to worry about transmission, by far, the number one way this virus is transmitted is close person-to-person contact via aerosol and via inhalation. That we do know, and it's becoming more and more clear as time progresses. So when we talk about how the virus is being transmitted, we now need to look at how it can be controlled. This is an old graph. This is nothing new. It's the hierarchy of controls that we use in epidemiology, disease control, even process safety within industries. Very, very simple models. When we look at the top of the pyramid here, we have the most effective controls, and the bottom is the least effective controls. And so what we always want to do is try and first focus on what is our most effective way of preventing disease transmission. So obviously, you eliminate it. If you can eliminate the disease or the source of the disease, you're going to have the most success. When we talk about COVID, the process of elimination, keep in mind, humans are the source. A lot of humans are asymptomatic or pre-symptomatic and don't know that they have the disease. So the best way to control the disease is eliminate the humans. And it sounds kind of odd. In this context, we look at quarantine. That's where we were for a while. If we put people in quarantine and keep them out of our buildings, we're eliminating the source. That is the best way to control disease. It is not practical for long term. And people are, we see that right now. It's an initial step. It's not a sustainable step. The second best way is substitution. Substitution is when we substitute something for something that's less hazardous. In this case, when we talk about viruses and disease, typically substitution is substituting people who we know have immunity versus people that are at higher risk. This is a big problem right now for COVID because the antibody tests, the ones that say if someone may or may not be immune, are quite frankly not very good. And we don't know how long immunity lasts, even if the antibody tests do show someone's carrying the antibodies for it. One of the things the CDC came out recently is don't make decisions based on antibody tests and letting people into your building. They're kind of taking the whole substitution control off of the table because they're getting way too many false positive results. And if you have a lot of false positive results, you have a lot of people thinking they're immune and they're not. And then they're walking around with maybe a little bit more cavalier and overconfident. So we're taking substitution off of this pyramid for now. When we get a vaccine or we understand more about immunity, we might be able to put it back on the table. Engineering controls, third best way, that's where we're going to be focusing a lot of our time for controlling COVID. Engineering controls can include touchless surfaces, getting rid of light switches in your building. A lot of people are touching automated doors, widening corridors, ventilation, bringing in more outdoor air, physical barriers. These are all engineering controls that you can put into your building to help reduce the risk and spread of disease. That's where a lot of this is going right now. There's a lot of even architects looking at future building design and how to implement the engineering controls, not only for COVID, but we feel that if we're controlling things for COVID, we might be able to contain and reduce seasonal flu or colds and improve productivity within our buildings, reduce disease in general. Next down the line is administrative controls. We're hearing a lot about administrative controls as well. Not as good as engineering controls because your people can bypass administrative controls. Administrative controls are policies we put in place. That's your 6-foot distancing. That's your staggered work shift, having people come in at different times so they're not filling up the elevators all at once. In theory, this works very, very well. The problem is we're dealing with people. When you're dealing with people, they don't always follow rules. So unlike engineering controls, which are designed into the structure of the building, the administrative controls can be defeated by people. Last on the bottom, but certainly not least, we have our PPE, our personal protective equipment. There is still some debate about it. I'm unsure why, but masks do work. They don't necessarily protect the wearer, for a number of reasons, but they definitely protect someone that's shedding the virus from potentially infecting others. Remember this, we talked about the direct personal contact. If you can keep those droplets to yourself by wearing a mask, you might not know you had the disease. You could be asymptomatic or pre-symptomatic. You're being courteous and you're protecting others. The reason the PPE is at the bottom of the table, again, you got the human factors in there. You're gonna have people that don't wanna wear it. You're gonna have people that wear it wrong. You're gonna have people that take it off. So PPE is below the administrative controls. It's below the engineering controls just because we have compliance issues. It doesn't mean it doesn't work. It works when people comply, but in general, people don't comply. So that's why it tends to be at the bottom of the pyramid. So with that being said, I hope this just kind of framed things for discussion and puts it in context for when we start talking about buildings. I know Brad's going to talk about other risks associated with buildings when people come back. I hope this provides some useful information and goes into what Ben's going to be talking about next. So I'll turn it over to you, Ben.
Thanks, Rob. It was really informative, and it really does frame what I wanted to talk about today. The way you discuss how people can bypass administrative controls, engineers can bypass engineering controls. And for years, as an engineer, we've been helping buildings bypass those controls. So, and mostly in the name of energy efficiency. So we've had engineering controls in buildings that could help limit the impact of the seasonal flu, limit the spread of any kind of airborne infectious disease, not the current one excluded. So, but we've done that to make buildings more energy efficient. And that's by reducing the amount of ventilation that we put into buildings. That's by putting in demand control ventilation strategies, all kinds of different techniques and things to try to, basically keep the comfort at a basic level or where people aren't complaining, but also optimizing energy performance. Now we're looking at, during this crisis, maybe that's not the right thing to be doing. Maybe there are times we should be considering the health and welfare above the energy performance of the building. So I'm going to talk a little bit about that in the plan for reopening of buildings. So most of what I'm going to discuss is based out of my preferred source of information for this, which are engineering experts at ASHRAE. ASHRAE has formed a task force on the epidemic. Much like Rob has said, the transmission of this is most sufficiently through airborne exposure. And ASHRAE has concluded that changes to building operations, including that of the heating, ventilating, and air conditioning systems, can reduce the airborne exposure. So this can be done through a variety of different techniques: ventilation, filtration, diffusion, increased exhaust. I'm going to go through a little bit of that here in just a moment. It is not ever recommended to disable your heating, ventilating, or air conditioning systems, as that can actually cause stress to the occupants and further make them susceptible to infection or disease. So as we go into the reopening phase of a building, ASHRAE's current reopening plan has put in place basically 6 different modes of operation that you can put your building in. But what they're essentially doing is saying, hey, you need to have a plan for running your building in an epidemic condition, and then you need to be prepared for that post-epidemic condition. And so during this epidemic condition, and I won't bore you with the eye chart. They've got a 110-page eye chart that kind of goes through the details of all these different modes of operation and best practices. So I'll kind of keep it high level. They're recommending that there be this occupied mode with a pre-epidemic capacity, which is basically occupying your building with, before the epidemic, it's the full capacity of the building. There's a mode of occupancy with reduced capacity, which most of us are starting to experience now. This is a very minor occupancy, a 25% occupancy, potentially up to maybe a 50% occupancy, but definitely not the full occupancy of the building. During the epidemic condition, they have an unoccupied temporarily, which is what we've probably experienced mostly over the last 2.5 to 3 months. And they also have operation of a building during closure for indefinite periods. So this is where you're just completely shut down. As I said, even in a completely shut down state, you shouldn't mothball your building. You should still be running it. And they talk about that in detail, about some of the best practices for conditioning the building during those times. Once you get into the post-epidemic condition, what they're calling the post-epidemic conditions in place, I think they try to get a good acronym wherever they can. They've got two modes of operation. That's prior to occupancy and considerations once your building is occupied. When it comes to operating and maintaining your building HVAC system, during the pandemic or even going out of it, one of the best practices that you can have is dilution of air. And dilution is bringing in more fresh air. The air outside is clean. It doesn't have a lot of harmful additives to it because we're tending to filter that out in our air handling systems in our buildings. So we can increase ventilation by using more economizer on our buildings or increasing the minimum outside air. Now, we're in conditions this week where it's 95 degrees and hot and humid outside multiple days of the week. And building engineers are clearly saying, I can't bring in 100% fresh air. I don't have the cooling capacity to do that. And that's accurate. So what you want to do is try to bring in as much ventilation air as you can right now. Increase your exhaust air to the limits that you can. If you have demand control ventilation, which is typically based on tracking carbon dioxide levels in your space, that would reduce the minimum ventilation kind of as a people tracker. Increase those limits where we might set it to something, a very low limit, like an 800 parts per million, increase it to 1,000 or 1,200 parts per million. Likely you're not ever going to hit those limits, but we want to try to bring in as much outside air as possible. We get asked a lot about, well, how does this impact the space? I have a building with variable air volume terminals throughout, and what is the practice there? And what we're looking at, I haven't seen this recommended by ASHRAE yet, but what we're recommending is increasing the minimum set points or the stop points on that. Normally, again, in the practice of saving energy, we reduce those as low as possible to save energy. But right now, you can bring in more localized ventilation, a higher percentage of that outside air that you're bringing in your central systems to the building by increasing your lower stops. Another couple things that you can consider doing is flushing your building whenever possible. Most of us, if you're in an office building, you're not occupying the building at night, and you a lot of times will shut down your HVAC systems altogether and let the building sit idle. It's recommended that during these times where the temperatures are conducive to bringing in a high volume of fresh air, to flush the building out overnight, to bring in a large quantity of outside air, run the systems with either a higher minimum or an economizer state, to bring in a lot of fresh air. This naturally will increase the exhaust and pull any contaminants of the air out of the building. If you live in a multifamily building, you're always bringing in a lot of fresh air because you have 100% makeup air units. In that case, you want to look at bringing more ventilation in, increasing the makeup air to the building if you've got it at a minimum. But in that case, you also need to increase the exhaust. So you want to be careful with air balance, especially in high-rise buildings. Pressurization you don't want to throw off. These buildings are all carefully engineered to have a pressure dynamic that helps promote very good air transfer from places, and you don't want to reverse that. And so sometimes if you just bring in all fresh air and no exhaust, you can cause a situation in your building where you're actually pushing contaminants into places you don't want to have. And likewise, if you're bringing all exhaust and no outside air in, you could be entraining things from outside or other parts of the building that you don't want to entrain into that space. Also, while you're in this time, if you've got anything that can re-entrain exhaust air, this could be exhaust going from intakes, windows, doors, or most particularly, not so much in Chicago, but outside of Chicago, a lot of buildings are fit with energy recovery ventilation. These can be wheels, but either way, these are places where exhaust air and outside air cross paths to save energy. And air can be re-entrained from the exhaust air side of that back into the outside air and bypass some things. So right now, ASHRAE is recommending, they've got a lot of recommendations for that, but in general, if you're able to bypass that in the pandemic condition, that is a recommendation. Indoor comfort is really, really important. We want to maintain temperature and humidity conditions that promote good health of the occupants. We don't want to go and make it super hot and super humid in the space. I've seen some research that suggests that this current SARS-CoV-2 virus has that doesn't like it when it's 86 degrees and super humid. So if you want to make the inside of your office building or your house like Singapore, I wouldn't recommend doing that. It might help you temporarily, but it's actually probably going to be more harmful to your health. It also introduces risks to your building, such as the creation of mold in surfaces, So you want to kind of watch what you're doing with temperature control. Right now, everybody's from ASHRAE is recommending maintaining your humidification levels relative to the indoor temperature between 40 and 60%. I always despise relative humidity because people don't always understand what it's relative to. It's relative to the temperature inside. So in the summer, we try to maintain a temperature of around 75 degrees for good human comfort. This is based out of an ASHRAE standard 55. They recommend a relative humidity range in the range of 50 to 60%. It varies. It can be a little bit higher than 60%. But for safety, we like to say between 50 and 60% at a 75-degree indoor condition is a good condition that helps keep you from having dry skin, which can cause cracks and lead you to further exposure to infection, not only from any kind of virus or disease that you can touch or feel or get contact to. Some research has suggested that lower relative humidities can rapidly change these particles, the droplet nuclei, as they call them, into increasing evaporation rates. So as they fall through the air, they evaporate and they can deactivate. That can be true. We're not sure about this current virus from what I've read, but the lower relative humidity conditions can cause that dry, cracked skin. So in the winter, particularly when it's of concern, in a 70-degree design condition, you want to try to maintain your building between 30 to 40% relative humidity. Now, that's fairly easy to do in a multifamily high-rise building. Most of the makeup air systems that support the building and provide the ventilation and fresh air and pressure control have humidification systems in them. And it's pretty easy to bring that into the building. In commercial office buildings, it's extraordinarily rare to have any kind of humidification. And the higher the fresh air, the more ventilation you bring in, especially in a cold condition, the drier the air is going to be and the more it's going to dry out the space. So there's a delicate balance here, and there's some engineering and thought that needs to go into how you operate your building to promote good ventilation, but not promote poor human comfort. When it comes to air filtration and cleaning and the technologies surrounding that, most buildings with a rooftop unit or a standard HVAC system will come with a fairly low MERV rated filter, like a MERV 8 filter. And there's a eye chart of MERV ratings I can provide. It's on our website and some of the other previous materials we provided. That's published by ASHRAE Standard 52. That rates filters between MERV 1 and MERV 16 on their effectiveness at removing these particles. As Rob mentioned, I think a lot of the research is suggesting the globs here in the 0.5 micron range is what we're talking about. So as we look at filtration, ASHRAE has a range between 0.3 and 1 microns that they rate a lot of their filters in for their efficiency at removing particles below that. So based on their research, and the recommendations out of ASHRAE 52, MERV rated filters between MERV 13 and MERV 16 are recommended to be upgraded in your building if you don't already have that. Most commercial building HVAC systems have the ability to accept these. These can be in bag filters that can be retrofit into the space. There is a penalty that you pay for putting a higher MERV rated filter in. For instance, to give an example, a MERV 8 filter that's dirty has about a 1/2 inch pressure drop versus a MERV 14 filter, which has a 1 inch pressure drop, or over double the pressure drop. So you're going to pay for a little bit of energy potentially there. However, that being said, there are technologies and filters now that can provide up to MERV 15, MERV 16 grade filter that come in a V-bank configuration that have a lower pressure drop. We've been asked the question by some chief engineers, should we be increasing the frequency of our filter change in our building? And the quick answer to that is no. There's no reason to take a filter out before it's past its useful life. Loading a filter, making it dirtier does not make your building any less safe. It can actually help the efficiency of the filter. It can capture smaller things because it becomes a little bit more plugged. Again, you pay that penalty, so there's this point of time where you need to know when you're going to change that filter based on energy and effectiveness. Some people ask, can I put a MERV rated filter in that's HEPA grade? This is the MERV 17 and above. Most commercial buildings don't have the HVAC systems with the horsepower to handle that grade of filter. These are really made for hospital surgical suites, clean rooms, and other kind of industrial manufacturing facilities where you need ultra high quality air. And while they're effective at getting very small particles out of the air, they're not intended for their use in this kind of environment. And another point about filtration is it's a capture technology. It's not a disinfectant technology, and it's not something that necessarily purely cleans the air. It captures these viruses and particles, but it doesn't deactivate a virus or clean the air. So one of the technologies that it can be used in conjunction with is ultraviolet light, which can deactivate a virus. So the ultraviolet light is a technology that can be fairly expensive to put in. It is common to see, particularly in air handling units with cooling coils, to look for bacteria, and it can clean the coils of the bacteria that can grow in the water side part of that. I think that's definitely Brad's area of expertise, are these waterborne pathogens and bacteria. But the type of ultraviolet that you want to be consistent to if you are looking into that technology, we only really recommend it being used on cooling coils and air filters, and it needs to be in that 254 nanometer wavelength, the optimal spectrum UVC light. You probably heard a lot of this, UVGI, or ultraviolet germicidal irradiation. This is a good wavelength, an optimal wavelength. It's just right up, I'm rounding up to 254. That's what you want to look for when you're buying this technology. But it needs to also be engineered. This is not something you just go to somebody, pick it off the internet, and buy it on Amazon and put it in the unit. Especially when you're looking at trying to put it in airstreams. There are duct cleaning UV technologies out there. They have to be specifically designed for the area that they're being put in, the airflow and the velocity of the air. Otherwise, I don't know if this has been hashtagged or coined yet, but I'm calling it a pandemic purchase. You're buying a technology that someone's throwing at you out of fear and not out of the proper engineering control that needs to be. So you need to be very careful that you're buying an engineered for your application when you're getting a UVC light. UVC is very damaging, and exposure to it needs to be limited to very, very brief periods of time. If you're maintaining it, UV bulbs require frequent replacement, rarely last more than a year. So depending on the length of application. So just some things to keep in mind about that particular technology. ASHRAE is recommending as one potential thing in atriums or large spaces where you have a high ceiling, using upper air zone disinfection using UVGI technology. Again, it has to be carefully designed, but that upper zone, that type of technology is proven to be pretty effective. It's very commonly seen if you go to a hospital, you'll see the UV lights being used for local surface and local air disinfection. Just a few things in air cleaning technologies. There are some other technologies out there. People ask about what can I do in my localized space. We've heard things about setting off ozone generators at night and letting them run, and then letting the air clean until people can move in. Do not do that. That's not a good technology. Ozone's very harmful to our health. That's one thing we know for sure, is it has negative effects on it. And there's conflicting data on the effectiveness of it in the use of actually combating a virus. There are things like plasma generators, electronic ionizers, bipolar ionization, photocatalytic oxidation. I'm not going to go through all of these things. If you want a good summary that kind of gives you the pros and cons, go to ASHRAE's COVID-19 website, and they have a list of all these technologies and all the research that they've done on it. And you'll find that very little research has been done on most of these technologies. Most of the claims come from non-scientific based research. Not saying that there's things that are good here, but or not going to work here, but you got to be careful that the technology doesn't cause more harm than it helps. So the last thing I wanted to mention on this is monitoring your environment. Sometimes I think we kind of feel blind to what's in the air all around us. And there is technology out there now that we can monitor certain things like particulates, volatile organic compounds. We've been watching temperature, humidity, and carbon dioxide in our space for years. But here in our office, we've installed a device about a little over a year and a half ago that we just kind of monitored the particulate matter. We get exhaust from diesel generators and things coming into our outside air, and we could see sulfur dioxide, nitrous oxides, and ozone levels and things like that, depending on the temperatures outside rise in our space. And it's a good indicator of how to look at your building. So you may want to consider monitoring some of your spaces a little bit more, especially places where you have high areas of congregation, to make sure that we're not compromising the good air quality for energy efficiency. And so I just wanted to really briefly ask one question on monitoring spaces is, Rob, can you monitor airborne infectious diseases in the air?
There's not much practicality to it. The technology is there. We can find the viral RNA in the air, but keep in mind that the person is the source, and it's not going to travel too far from the source, and you don't know who is carrying the virus. So from a practical standpoint, you're going to be taking samples, air samples from people's personal space. You're going to be sucking air right in their, within 6 feet of them, not knowing who has the virus and moving around with them as they move around. So from a practical standpoint, the technology is there, but it's not very useful to collect air samples, and generally is not recommended outside of a healthcare or hospital. If you're in a healthcare or hospital, there may be some reasons to do it, but in commercial office space, no, we don't recommend air sampling for viral particles.
Thank you. On that, I'll ask the question to Brad. Would you be willing to take the first drink of water in an office building that's reopening?
No, but I think Rob would be. So good morning, everyone. I'll try to keep this quick so we can get to some questions. The funny thing about this slide is my 13-year-old daughter and Rob Rodersman, a renowned expert, had the same reaction, was ew, gross. That could be the same reaction that some of our building occupants will have when they come back from work, that these buildings have been sitting stagnant or partially unoccupied since the beginning of March. And we don't know what's in the water system, what has been going on in these pipes. Have they sat with stagnant water for months? Have buildings been flushing all the faucets and control points and valves and whatnot? We do know that most of the buildings have not been operating normally. The demand for water in these systems is significantly down. So you're actually not bringing in as much water from the city itself. So the worrisome would be what's in this water. Are there metals such as lead, and are there biologicals, specifically Legionella? Now, focusing on lead, we know that lead can enter the water systems or in buildings from a variety of ways. Lead pipes, lead fixtures, lead solder, and with water being stagnant in these pipes, there's a possibility of just pure leaching from the pipes into the water. Now, who's at risk with elevated levels of lead? That would be more of the children. Obviously, if you have a daycare or any type of children in your building, you're part of the EPA's testing, or the Illinois EPA's testing that's been going on for the last few years. But also pregnant women and other susceptible individuals would be at risk. Really, the only way to tell if you have elevated levels of lead in your water would be to sample. And it's a relatively inexpensive sample per location, and you can get results relatively fast as well. What can you do? Once again, you can flush the systems. It may require a lot of flushing and multiple times of flushing to clear the water up or to move all the water through a building. So the other concern would be Legionella. And where we would get, once again, Legionella is naturally occurring. It can enter the building through municipalities, or it can amplify within the water system of your building if you have dead legs, anywhere where you have a biofilm that has developed over time, and especially, as we've had potentially water sit in this water system, in your water systems for months, with very little to no flow in some areas, or abnormal flow. So you may be getting certain areas that are basically dead spot. The possibility of biofilms developing is rather high. And then once again, you'll likely have the bacteria in the water, but you can have amplification. The other problem with stagnant water is any disinfectants that may have been through the city or municipality or entered into the water system at the building, especially like free chlorine or any of those, they dissipate after time. So if that water is stagnant, the free chlorine will dissipate and it'll move on. And so you will have very little biocides in the water for a significant time. So that would, again, allow for amplification. People that are at risk are, immune compromised, elderly, and the symptoms, the scary part for Legionella is when individuals are exposed, whether it's Pontiac fever or other diseases, the symptoms are very similar to COVID-19 symptoms. So that's the scary part. They may falsely think that they've been exposed to COVID when they actually have been exposed to Legionella. Some of the things that you could do to prevent is monitor for disinfectant, test control areas for whether you have chlorine, the pH of, and then also the water temperature. Where is this water, where it's been sitting or not been used regularly? What is the temperature? Are we at the optimal growth points of Legionella? So it's like 75 to 108 degrees Fahrenheit. The other thing we could do is flush the system. Now with Legionella, we have to be careful when we flush the system because exposure becomes when you aerosolize Legionella. So showers, humidifiers, spas, fountains, if we are flushing those, we want to make sure we do it so the occupant who is flushing is not exposing themselves. And you can follow your water management plan. I'm sure some building owners and managers have water management plans. Hopefully they've been following that during this pandemic, but it's possible and it's likely that some haven't, so that may have to be revisited. Once again, the only way you can tell you have Legionella in the water is to test it. It's not, if you follow the ASHRAE 188 document and the CDC toolkits, testing is not your first go-to. You do want to look at other reasons and try to find out if and when testing is necessary. And that's something that, obviously Rob and I could help with, or if you have a water management plan, it should be in there as well. So with that, I'll kind of leave it open to everyone for questions unless anyone else has something for me.
Appreciate all the insight, Brad and Rob. And Brad, when it comes to water management plans in a building, I know that goes obviously beyond the Legionella concern into all these other elements that you're talking about. How would you go about getting one of those started? Like, what would be one of the first steps you would take in planning? Because I know a lot of buildings probably don't have one right now, and I think we'd be interested to know what would be the process of going through creating one of those.
Yeah, I mean, really, you're going to try to follow a combination of the ASHRAE 188 and the CDC toolkit, and you're going to have to get like an overview of the building and try to find out if and where their risk points are, and then you develop off of the whole building itself, and then where potential risk points are. So it's usually like a walkthrough of the building, try to find out, what's really going on with the building.
Oh, great. I had a question for you, Rob. What do you see for like surface testing and things like that in buildings as far as, there's been some discussion about, you can pick it up off of surfaces. I know in elevators, people are looking at disinfectant pads over the buttons. People talk about chemical cleaning at night and things throughout the building and things that we want to make sure we have some ventilation for if they're using certain chemicals throughout the night to kind of purge the building. But I wanted to maybe get your perspective on what you've seen as far as surface treatments and testing within the building.
This is a hot topic, and this comes up frequently, is should we test our surfaces to make sure they're clean? And I think what you just alluded to almost answers the question. Was you first need to have a plan in place. You need to how are you going to deal with the elevator buttons? How are you going to clean? What's your overall approach? Sampling of surfaces is just one tool in your toolkit to maybe go back and verify that your surfaces have in fact been cleaned properly. There's a lot of limitations to sampling surfaces, however. The technology can't differentiate between live or dead virus, and it's pretty much a presence or absence test. It's either there or it's not. It's relatively expensive, a couple $100 per sample. The average sample is covering only maybe 100 square centimeters at most, and your building's probably potentially hundreds of thousands of square feet. Also keep in mind you get results back in 2 or 3 days. So if you've cleaned and you sampled and there's people in the building, those people could have recontaminated the surfaces in the time it took for you to collect the samples and get your data back. So there is a a purpose to it, but you got to think it through. You just don't go out there and collect samples for the sake of collecting samples, because you could just confuse things.
We have a question. Question is, you mentioned touchless fixtures. Don't you lose your water conservation measures if you install these on your toilets? I can maybe field that one. There was an interesting study done by, I guess, U.S. Equities at the time, back in probably maybe 10, 15 years ago, where they literally had someone stand at the door of a men's and women's bathroom where they had installed, it was at the tollways, the Illinois tollways is where it was, and they had someone stand there and record how many times the automatic toilets would flush when they went into the stalls. And they found that with the touchless sensors, yes, they flush, I think, 2.3 times per person or something. I forget exactly. I'd have to go back and look through my notes. But it was a kind of a fascinating thing that, you know, these fixtures work in a certain way. So there is a potential for that with the toilets, that you could lose the water efficiency. But again, I think it comes back to kind of the trade-offs of what I was mentioning during the discussion of energy versus ventilation. Is there's always been that balance of what's more important, fresh air or energy efficiency. And I think you just have to look at the times that you're in and what the impact is. I think it comes down to, and maybe Rob or Brad could talk about it, but the risk factors and associated with the plans that you have in place for your building, and weighing those risks in that plan to understand if it makes sense to do that. Is it okay to have a flush handle on a toilet because you're going to use a sensorless faucet and sensorless soap dispenser to wash and wipe your hands when you're done? Those are things that I think you need to take into consideration. I don't know, Brad or Rob, if you have anything to add.
I mean, just a little interesting historical note. And I think you summed it up really, really good, Ben. It's you know, it's a trade-off. It is a trade-off, energy efficiency sometimes for safety. You know, we saw that in the 1970s when we started building buildings really tight, and we had all the indoor air quality problems. We were saving a lot of money heating and cooling them, but we were creating other issues. Interestingly enough, what Brad was referring to with the Legionella bacteria, we have seen cases of Legionnaire's disease increase fivefold in the last 15, 20 years, to the point where we have 70,000 cases in the United States per year, upwards of 10,000 fatalities. I mean, in the context of COVID, that's not a lot, but it's substantial because it's every year. And we've seen this increase coincide with a lot of the water conservation, where we start having less water going through your buildings. As Brad mentioned, the residence time of the water is longer in your building. So you have the chlorine dissipates, biofilm builds up. You also have less velocity through your pipes, so you're not scouring off the biofilm. So yes, you will lose some energy efficiency with the touchless and all kinds of other things to deal with your water fixtures, but you're potentially increasing the water quality. And I think there needs to be a balance in there. And with the flush toilets, I mean, if you have an area where people don't use the toilets very often, perhaps leaving the automated flushing off would make sense. If you have one that's used very frequently and a lot of people are going to be touching it, it's going to be flushed frequently anyway. Maybe that's something that you do go touchless with and manage the risk that way.
That's interesting. I had a kind of a follow-up on not necessarily the water efficiency part of it, but as the disinfectant part, as you're getting lower flow and more buildup. I know the state of Illinois plumbing code is considering a change to increasing the water storage temperature to 160 degrees Fahrenheit. And I didn't know if you had anything to comment on that.
Yeah, that's, again, we have, and I think Brad could speak on this as well. It's the balance of, we have 140 degrees kills Legionella bacteria slowly, 160 pretty much wipes it out. So you're going to kill the bacteria and scald your building occupants unless you get them mixed up. Or something like, you know, yeah, you need to get something to control the temperature at the point of use. Yeah, otherwise you're substituting one hazard for another.
Yeah, great. Do we have any other questions from anybody here?
You know, you mentioned probably not going to HEPA filters, but do you, with your clients, do you see them upgrading filters in the time of COVID right now? And if so, what are they typically going to? What MERV level can the buildings, you know, handle without causing, like you said, without having sufficient horsepower to handle, but still be effective at reducing the transmission of disease? No,
that's a good question. So for years, we've been looking at things like high-performing buildings. You know, we work with a lot of people that get LEED certified or go after a Green Globes type certification, well building standard. They're high sustainability thing, and they recommend that they put MERV 13 filtration in as a minimum. That's always been kind of the lower benchmark for a healthy green building. What we've seen and what we've recommended over the years through our energy efficiency work, when we do a retro commissioning type project, we'll see a building that might currently have a MERV 11 or MERV 12, which is a pretty common commercial grade filter. And we'll recommend actually they increase that filtration to 13, 14, or 15. We don't typically see 16, but we see MERV 15 pretty commonly in buildings. And the way that I mentioned this in the presentation, but they can handle this without really any increase and sometimes a decrease in energy with a V-bank configuration filter. And V-bank is literally just taking a filter that normally be flat facing, like a box filter, and it stretches the filtration media up into a V shape to give it more surface area. So because you're running the area at a lower velocity through a bigger surface area, it has a higher effectiveness, and it doesn't have as much pressure drop associated with it. Okay. So most of the buildings we're seeing going to that configuration and we're having them take their pre-filters out as well. So they might have a MERV 8 pre-filter on that. So they're reducing a little bit of pressure drop from taking a pre-filter out, but they're reducing the ultimate pressure drop by putting this V-bank configuration in. So I'm not endorsing them, but they work really well. They last a long time, and they're pretty effective. And MERV 15's right up there. That's a very good, I think it's 85% efficient at capturing particles below 0.3 microns. So it's a pretty good filtration media if you're going to go there. We have a question here. Do you recommend a well building certification? And if so, which one, or how would you say we should go about it? It depends. If you're a commercial building, there's the LEED certification, there's Green Globe certification, there's well building, there's Fitwell, there's all kinds of different green certifications coming out, and they do have different practices with them. When it comes to things like well and Fitwell, these types of certifications are actually getting into your tenants and their tenant activities. And I think they're more geared towards this conversation around a healthy, good building. Their well buildings pretty extremely expensive, but it gets into like the types of food you're providing occupants in common areas. It gets to how your cleaning practices a lot more than the LEED certifications do. It goes a lot more into the air quality. It's based out of research, university research that went through productivity and how to increase occupant productivity in the work environment. I think a well building standard is not very well suited for a multifamily building. I think things like your Green Globe standard or LEED standard fit those a lot better. But the Fitwell is one of the standards that we're seeing come on the marketplace for tenants and tenant engagement. And a lot of tenants are asking for that. So it really depends on your building and who's occupying it. If you're multifamily, if you're commercial, if you're single tenant, multi-tenant, the standards are all different. They all have different price points. So there's that factor of it as well. But all of them, all the green standards do focus on this balance of well-being and energy efficiency. And just one other point back to the filtration, I'm thinking about multifamily or even single family occupancy. When it comes to filtration, there's a limit usually in the type of filtration you can use in your home. If you have a home furnace, you might not be able to put a higher grade filter. A lot of the 3M or Honeywell filters will advertise a MERV 11 rating for something if you want to work with pet dander and you're hypoallergic to your pets, and it's good at capturing those kind of allergic particles. But once you start getting above that, your furnace might not be able to fire because the pressure drop of the filter is too great for it to get sufficient airflow for the natural gas to ignite and combust. So there are considerations. You want to be careful that what you're doing fits your application. You want to make sure that it doesn't change the application, make your indoor environment worse. So just a couple minutes on the hour. Is there any other questions from our audience? If you do have any, our contact information is up on your screen. You're more than welcome to reach back out to us at any time. I want to really thank Rob and Brad. Thank you very much for joining us today. It's been a pleasure, great insight. Really appreciate everything you brought today. And thank you everybody who joined us today. Really, really appreciate it. And again, if you have any questions, feel free to reach out to us.
And thanks for inviting us, man. Thanks to Cyclone Energy. I really appreciate the opportunity.
Yeah, thank you, Ben.
Our pleasure. Everybody have a nice day. Stay safe and well. Yep.